Hello and welcome to my talk about cellular modems and especially about the way how we talk to them using microcontrollers. My name is David Čermák. Here is a brief introduction of myself. I am an embedded software developer, also a contributor to ESP IDF and an Espressif employee where I'm currently leading a team of network developers. So that was about me, and now about the talk. We'll be talking about cellular modems. So here is a motivational picture of an old style analog modem with an acoustic coupler. Because in the past, we used to have telephone lines with real actual wires. And if computer A wanted to talk to computer B remotely over the telephone line, they needed some device in the middle, some translator from the computer A to from the ones and zeros to that analog signal. Nowadays, we don't no longer need those wires, but the idea is still the same. So if we wanted to make a phone call, we use cellular phones and connect over cellular networks. And the same applies to modems. So, but the computers still need some middleman, some device in the middle that would translate those signals from them to the signals that are applicable, that could be sent over a cellular network. And this is actually the topic of my presentation, but we will not be speaking about cellular modems, but especially about the way how we talk to them. So about the interface between the microcontroller, because in this case, computer A is a microcontroller and computer B is something like a gateway, internet gateway of your internet service provider. And the other device is the cellular modem. And we usually talk to them using UART and with AT commands, but it's not that simple. And let's see what are the agenda for us and for today. So first of all, a brief introduction about protocols and interfaces that could be used when we are talking to modems. Second chapter will be about two basic modes which we can basically work with modems. So we can either use command mode, sending commands, request response type of communication, or open and establish a network. The third part of the presentation will be just about tips and tricks, how to use commands and network at the same time, and some other ideas how we can improve reliability. Also in the section number 4, OTA, because if we want to perform over-the-air updates on an interface which is by nature really slow, there might be some issue with reliability and so on. And the last section will be about ESP IDF solutions, so about the components, examples, and demonstrations that we could provide if you are using Espressif chips. So let's start with protocols and interfaces. As you can see, here are some of them, but basically we can take a look at the most popular modems that we can buy and look at data sheets and look at all features and interfaces that they provide. So here are some screenshots from the data sheets, and you can see a recurring pattern. So if I actually summarize this, we can actually list all or the most popular interfaces as these, and protocols as those mentioned here. In this presentation, we're only to focus on the UART and USB interfaces and only on these protocols. I've deliberately shaded out all those interfaces here, I2C, SPI, PCI, and MBIM for protocols, because first, we don't have really a solution for espressif chips, and second, these protocols and interfaces are rarely used when we communicate with modems. All right, let's go to the second chapter about commands and network. So I've already mentioned that we have two modes, basically. One is the command mode, when it's a request response type of command, so perfect for sending commands, setting properties, getting properties, or for example, sending a text message, getting GPS information. But it's not that great for serving and network communication because of the nature of the network, which is basically asynchronous. So for network, we usually need to establish the connection and maintain the connection. And that's by nature not really a request response type of communication. Now let's look at the commands. So I think we all know that basically we communicate with those AT commands. So AT supposedly means attention. So we say, well, attention please. An important command is about to happen, and the other party just responds with OK. So it's a very simple textual style of protocol. We send some information with some parameters, and we usually get OK or some response with OK. So like a very simple protocol. Nothing really to talk about. And now, what about the network? So with network, it's a little bit complicated. I already said that response or request response type of commands are not that great. But as you can see, I'm actually trying to serve network with AT commands here. So I'm actually trying to ping www.espressif.com using AT commands, so sending this cping messages, and I'm also trying to send HTTP requests to this espressif.com web page, and so it's not very, and as you can see, I'm getting a buffer overflow. So it's not really a convenient API, but it is possible. As for the PPP protocols, this is something different. It's actually a full-featured network protocol. It's a collection of point-to-point protocols, and here we may basically go back to the very first picture on this presentation, where two computers are making a phone call. So for that, it's probably really nice to think about it as 2 points talking to each other. So PPP actually means point-to-point protocols. So it's not a single protocol, it's a collection of multiple protocols, but the idea is that it basically creates a tunnel between IP tunnel between computer A and computer B. And as you can see, it's no longer a textual type of protocol. It's a binary protocol. You can probably see some ASCII data here, but these are basically ICMP payload. So this is basically a ping request which is sending this payload, and ping reply is basically repeating it back. So one important thing to note about those PPP protocols is that those protocols are usually part of our TCP/IP stack. So when we establish this kind of connection and we maintain it by our TCP/IP stack, then we basically create another network interface which could be used in a standard way, so that we can basically use this connection to the modem as another network interface, the same way as we use Wi-Fi, Ethernet, or something else. All right, so that was basically the brief introduction about the possibilities and now and the two modes, and now what we can do if we want to use these modes together at the same time. We have basically four options. We can switch between the modes, so whenever we need PPP or network, we switch. When we need to send a command, we switch back, and so on. Number two is using CMAX, so basically multiplexing these two protocols onto one channel. Solution number three, and I've already shown that when I was trying to basically ping espressif.com using AT commands. So we can basically serve the network simply just using AT commands. There are some issues with that, and I will talk about them later. Number four, we can basically use two physical channels. So looking at I'm sorry for that. Looking at the point number one, switching between modes. Switching between modes, it's possible, but the switching sequence is kind of slow. So let me try to run this screenshot that was basically taken while I was basically repeatedly switching between PPP and command modes. So you can basically see that it takes about a second to switch from command mode to PPP. Now we are in PPP, and now it takes something more than a second to switch back. So it is slow because there is a mandatory pause between sending an escape command in the PPP mode. So it's not really useful for simultaneous request, but the big benefit here is that for that we don't really need a library or any specific implementation, because sending AT commands or implementing this sequence is really very simple. And assuming that your TCP/IP stack supports PPP protocols, then everything is just ready and ready to be used. So yeah, this is basically very useful for applications that just need send commands and occasionally connect to network, or some applications that basically sleep most of the time, and some from time to time they wake up, establish a connection, send something over a network, and go to sleep again. Now the CMAX mode. This is the most traditional approach for basically multiplexing two channels or creating two virtual channels over one physical channel. It's basically very useful for situations where we need to access both network and commands at the same time. And the idea here is that first of all, as you can see in this screenshot, first of all, we need to establish this this CMAX mode. So create two virtual channels, and then I'm actually sending an AT command, and as you can see, the AT appears also here. So this is basically the payload of the protocol, but the CMAX add some header and some footer to the protocol. So it's just a transparent protocol which basically wraps this payload and sends it without any kind of modification. And as you can see, I basically switched the protocol and sent the AT command again, but to a different terminal. But the response is still the same. So this is the idea of CMAX protocol. So we basically create two virtual terminals. One we use for commands and another one for network. And it works pretty well, but for that we actually need a library. We need some implementation because it's not so easy to implement it in a user space. And also the protocol itself might differ. So there are some limitations or I would say, little violations for some devices, and I will also talk about them later. So that was about the CMAX mode, which is, as I said, it's perfect for applications that need both command and network at the same time. And also, if you can basically choose the device, because not all devices supports that. All right, networking with AT. So that's also one of the options. We don't need to switch modes. We just stay in one mode. We already know that it's not perfect to maintain or serve the network operations with AT commands, but it's available everywhere, and it's there, and it might save us some trouble. Unfortunately, these network commands are different device per device. I already mentioned that there are some standards for AT commands, but those network commands, they are very specific and they basically don't fall into any kind of category of standards. So every manufacturer defines their own network commands. Now we have these two drawbacks. One is security and one is protocol libraries. So what do I mean by that? So security, if your modem actually supports HTTPS or MQTT over TLS, that's great, that's secure, but it's secure from the frontier, from the modem side upwards, up to up to that cellular network or to the internet. But we basically expose the insecure part or the plain text communication between the chip and the modem, which is or could be available if someone gets the physical access to the device. What I mean by protocol libraries. Basically, if we use one protocol library for communicating over Wi-Fi or over Ethernet, we cannot use it for communicating using modems. We need to implement our own library or our own commands that would basically work with AT commands. And why question marks? I will talk about that later when I will speak about Espressif solutions. So we do have some solutions for that, and I will just also show some examples how this can be managed. Yeah, and where it is useful, of course, for applications that need just command interface with occasional networking. The last option, using two physical channels, that's usually best choice if your device supports it. The only potential drawback is portability. If, for example, we need to use another device that might not need to support it. And this is also great for devices with USB interface, because these two physical channels, they don't have to be real physical channels or almost physical channels inside one USB interface. Let's say two endpoints in one USB interface. All right, that was about the simultaneous modes or using command and network mode simultaneously. Now, other tips and tricks about connectivity, OTA, and other stuff that we can improve. I already mentioned that OTA might not be very reliable if we are basically using UART and very slow baud rates, very slow throughput. So in some cases, we could get buffer overflows or something like that. So especially for UART, we can use flow control. So if it is available, if it is possible, not all devices support it, but if it's available, just use it. Another point, LCP echo. LCP is a sub-protocol of PPP protocols. use it if possible, because this is the protocol that basically checks connectivity, checks local link if it's up and running. So it periodically sends, it actually implements some sort of a keep alive mechanism. So periodically sends requests and check for replies. And if if a reply doesn't come, it basically treats the channel as disconnected. Some other issues that we might face, so during the OTA operations, some of the flash operations might take too long, and we might not be able to serve network during that operation. So we can basically perform OTA into phases. So we can basically download the image metadata, check the image sizes and versions and stuff like that, and decide if we want to update or not. And if we do, we just basically pause the network, perform bulk erase. During this operation, the network would be inactive. And then after that, we just resume network operations and continue with OTA. Some other ideas or options that we can do, we can adjust some lower layers of libraries, put handlers into IRAM, extend buffer sizes, or adjust baud rates. And this is probably all from the generic part of my presentation. And now let's go to Espressif solutions. Yeah, so I already mentioned that it is possible to perform some basic modem connection without any kind of library. So here is a solution for IDF only, and from IDF we will use LWIP's PPP layers, implementing the the PPP protocol. So here is a link to a very simple example which just establishes a connection, sends just a few AT commands to set the modem to the PPP mode and start and maintain the network connectivity. It's very short, and it's basically part of this multiple NetIF example, which uses Ethernet, Wi-Fi, and LTE, or connection over a modem at the same time. Here is a link to that. So if we want to use a library, Espressif offers a library that's called ESP modem. It's basically deployable using standard way, using ESP registry. And it contains features and examples that are listed here. So for example, for CMAX support, you can check this example. If you want to play with power saving modes, we also have an example for that. Here is a link. Known issues, it's a very interesting and important section of our documentation, because it basically lists all the possible violations of the protocols of some devices that we came across. And I was talking about that during the CMAX part of my talk that some devices might deviate from the protocol a little bit. Some of them might not support it at all. So please check this link if you want to use CMAX and you are basically deciding on which modem, which device you wanna use. TCP client with AT commands. Here is a link to that example, but I will also talk to it a little bit in more detail because I wanted to basically highlight two solutions that we use. The ESP modem also has Linux port. Here is a link to an example. So you can basically run the same source code on ESP32 and on Linux or on Raspberry Pi and use the same modem. Also, one important link, modem console. So all these screenshots and little videos that I've been showing today were actually taken or captured while running this modem console example. And it's basically a very simple ESP console that implements very few AT commands, or allows you to send any kind of AT command that you would like. And it also implements, the basic mode switching. So you can basically, just running this example, you can basically play with all the modes and AT commands for your specific device and experiment with that. Now, just a few notes about this TCP client with AT. I've already mentioned that was the solution of using commands and network simultaneously, but only using AT commands. And I mentioned that there are two drawbacks basically, that for that we need to basically implement our own protocol library, but here are some workarounds how we can basically how we can address this drawback. So if you already use the some ESP IDF protocol libraries, for example MQTT, you know that we use this component called TCP transport, which is kind of a nice component because it allows us to basically layer different transports on top of each other. And in this case, it is the usual case that we run TLS on top of TCP, and then we basically connect to our TCP IP stack and to Ethernet or Wi-Fi or something like that. But in this example, we can basically create a custom TCP transport using those AT commands. So basically use the TLS layer from ESP32, from ESP IDF SDK, and just replace the TCP layer and use ESP modem to communicate with modems. So this will basically address both the security issues, because the security is handled here within the chip boundary, and protocol library issue, because we still use the same library. So that was the solution for our IDF protocol libraries. But what if we have some other protocol library that doesn't use the TCP transport? Well, here is a trick that we can basically use, and we also have an example of that. So instead of connecting to your endpoint, we basically could connect to a local host and use LWIPs or any kind of TCP IP stack loopback interface. So your user application would basically connect to a local host interface, and ESP modem would inject here a very simple local host listener and would just translate all what comes here to the ESP modem layers and implement the AT protocol that would send it to the network. And again, in this case, this is a little trick, because it consumes probably more sockets, 2 more sockets from the TCP IP stack. But this is a trick that also could be used, and it solves both the security problem and protocol library problem. And this is basically all from me. And on my last slide, I would like to sum up the entire presentation in these 3 sentences. So if you need to use commands and network at the same time, you can use CMAX protocol. If you experience buffer overflows with UART, just use flow control. And if you want to check something, experiment with something, or test something with the real actual modem connected to your device, just run this modem console example and play with that. And this is basically all from me. Thank you for watching.